my dear students. Now we are going to discuss some exercise problems. Exercise 2.2. For that, first one, find the LCM and HCF of three number. So already you know that the HCF and LCM of two number. Now you are going to study LCM and HCF of three numbers. Here 12, 15 and 21 given. You know that how to find the prime factorization of each number. So 12 we can write 2 into 2 into 3 of your division method. So we can write this one as 2 squared into 3. And here 15 we can write 3 into 5. 21 we can write 3 into 7. Now the HCF of this three number is 12, 15, 21 is 3. Why? Then now prime number should be all the numbers. So here 3 is there. So we can choose 3. Here 2 squared. So here 2 is missing in the second one, and here 2 is missing in the third one. So remove other numbers, other prime numbers. So only you want to choose 3. So that is in minimum power. Now other way, how can you write? Here 2 is missing. Now we can write 2 power 0. Here also 2 is missing, so 2 power 0. Now 2 power 2, 2 power 0, 2 power 0. So we can choose 2 power 0, that is minimum power. So anything power 0, 1. So that's why we can include. So here you can write 2 power 0, 2 power 0 value 1. Okay. So you can choose this number, but don't go like that. Just choose the number whether it's in all the prime number, all the numbers or not. Right. Now the HCF of this three number is 3 and the LCM of this three number is, just go to 2. Now 2 squared. Here there is no 2. Choose the highest power. So 2 squared. And the next one 3. So 3 it's in all the number. You need to choose the biggest power. Power is 1. So you can choose. And 5 we need to choose. And 7 also we need to choose. And finally this product 4 into 3 into 5 into 7. The product is 420. So this is the LCM. Okay. So from this question you need to understand. Already you studied HCF and LCM of two number. That is, you studied HCF of A comma B into LCM of A comma B equal to A into B. Here you have three numbers. Now you can think that HCF of A comma B comma C into LCM of A comma B comma C equal to A into B into C. This one is wrong. So that things is not satisfied for your three numbers. Now we just go to next problem. 17, 23 and 29. 17 is already prime number. 23 and 29 is also already prime number. Now HCF of this number is 1. Now LCM of this number 17 into 23 into 29, we can find the product because all are prime number. So that product is 10,557. Next, go to the third problem. 8, 9, 25. 8 we can write 2 into 2 into 2. 9 we can write 3 into 3. 25 we can write 5 into 5. Now all are 2, 3, 5. So 2 is not repeated, 3 also not repeated, 5 also not repeated in among 8, 9, 25. So HCF is 1. There is no common prime numbers among them. So therefore HCF 1. Similarly, next LCM 2, so 2 power 3, 3, so 3 power 2. You can write this thing also 2 power 3, this thing also 3 squared. This thing also 5 square, no. So you can write 2 power 3 into 3 squared into 5 square. The product is 1800. Right. Next problem. Given that HCF of this two number equal to 9, find LCM. Already you know that HCF of A comma B and LCM of A comma B equal to product of this two number. Now the HCF of A comma B is given as 9, substitute, and the LCM of this two number we need to find, and finally the product of this number, that is 306 and 657 product. Now we need LCM. So LCM equal to this number product and this 9 no left side in product, so right side is you can write as division. So 306 into 657 divided by 9. So LCM of this two number equal to this two number divided by 9. So double 2 into double 38. This is the answer. Right. Next problem. Check 6 power n can end with the digit 0 for any natural number n. If 6 power n for any n where to end with the digit 0 would be divisible by 5. Then that is the prime factors of 6 is 2 and 3. 2 into 5, then only that digits end with 0. 10 no end with 0. So 5 is not the prime factors is not 6. So consider only 6. 6 power n it's also repeated, right? But the prime factors of 6 is 2 and 3 only. 5 is not a prime factor of 6 power n. 2 and 3 only prime factor. Suppose 4 means, suppose 9 means 9 power n. So 3 only prime factor. 3 square the whole power n, that is 3 power 2n. Okay, like that any number, suppose 21 power n. So you can write 3 into 7 the whole power n, that is 3 power n into 7 power n. Like that, the prime factors of 6 is 2 and 3, so that is 6 power n you can write 2 into 3 power n, that is 2 power n into 3 power n. So 5 is not a prime factor of 6 power n. So by the fundamental theorem of arithmetic guarantees, there is no natural number n for 4 power n end with the digit 0. There is no such natural number is there. So like that you can find your answer. So like that you can give your solution. Right. Next, explain why this number 77 into 11 into 13 plus 13 and another form or composite number. Now just first find first problem, 7 into 11 into 13 plus 13. Now consider these two are two terms because they are product, so it's one term, it's a second term. Now 13 is repeated common, no, we can write as common. So 13 into 7 into 11 plus 1. So 13 we can take an outside. So 7 into 11 plus 1. So 13 into 77 plus 1, 78. So 13 into 78. Now the prime factors of 78 is 2. After cancelling this, we can write 2 into 3 into 13. So 2 into 3 into 13. That is 2 into 3 into 13 squared. All are prime number. So by fundamental theorem of arithmetic, you can tell every composite number can be expressed as a product of prime factors. So this is a product of prime factors. So definitely this form is a composite number. Using the fundamental theorem of arithmetic, you can conclude this. Next problem also 7 into 6 into 5 into 4 into like that given plus 5. So 5 is common among these two term because plus no. So this is considered as a two term. Now 5 into remaining 7 into 6 into 4 into 3 into 2 plus this 5 no, we can take outside. Here also into 1, so plus 1. Here also into 1, so plus 1. So like that you can consider. So plus 1. So 7 into 14 into plus 1. So that is 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1. Okay. Now 5 into, we can write the product answer. So the product answer is 7 6 are 42, 4 3s are 12, 12 2s are 24. So product. $1,008 plus 1. So that is 5 into 1009. Now we are going to write the 5 into 1009. No. Now you can write the prime factors as 1009. If you return this, you can tell all the terms are like a prime factors. So that by the fundamental theorem of arithmetic guarantees, it's a composite number. Now we need to divide this thing by your prime number. So divide 1009 by, suppose 2 it's not possible, 3. 3 means 3 3s are 9, remaining 1, 3 3s are 3, not possible, 4 5 6 like that. Just find the prime factorization of this one. If this number is a prime number, automatically you can tell this one is a product of prime number. So this guarantees that with the fundamental theorem of arithmetic, this number is a composite number. So okay, now I am going to give one idea. Okay, that idea how to check 1009 is a prime number or not. Okay, now like that any number, how to check whether it's a prime number or not. Now just go to the next perfect square number. Here you have 1009. For that 31 into 31 not possible, 32 into 32. Thousand and 24. So choose next perfect square, that is 32 square. Okay, now 32 square. Now consider less than 32 prime numbers. The prime numbers are 2, 3, less than 32, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 and 31. Now try to divide this 1009 by these numbers. If these numbers not divide over 1009, automatically the given number is a prime number. So 2 not possible, 3 already we checked, 3 3s are 9, remaining 1, 3 is so not possible, 5 not possible, 7 1 7s are 7 for 7, 1 7s are 7, remaining 3, 4 7s are 28, remaining 2, so 7 also not possible, 11 99, 9 9s are 9 11s are 99, remaining 1, so 19 not possible, 13. So here how many 13s are there? 13. So 1 7s are 7, 3 7s are 21 1, 1 7s are 7, so 91. So here 91, remaining 9, so 13 also not possible. Next 17, so 17 with 6, 17 with 5, so 85, so remaining 15, 159, 159 and 17 not possible. Next go to 19, so 19 5s are, so 95, so if 95 remaining 5, 59, 59, so not possible, so 19 also not possible. Next 23, 23 4s are 12, remaining 1, so 92, remaining 8, so that is 89, so 89, 23 also not possible. Now 29, 29 into 3, 97, remaining 3, so 39, no, 39 not divisible with 29, so 29 also not possible. Next go to 31, 93, remaining 7, 79, so 79 also not possible. So not possible from 2 to 31. So we need to check the given number is a prime number or not. How can we check? Just go to the next perfect square number. The perfect square number is how to check, because we can write easily 32 squared, 31 squared, 31 squared, 31 31s are 961, 32 squares are 1024. So choose 32 square. Now consider less than 32 prime number. The prime numbers are 2 to 31. Just start to divide the numbers. If the given number is divisible by any number, you can tell it's divisible by, that is, it's a not a prime number, composite number. Suppose it's not divisible by any number, you can tell it's a prime number. Now 1009 is a prime number, so you can tell it's a prime number. So every number can be expressed as a product of prime factor, like that you can tell. Right. Next problem. Just the question is, the speeds of two different persons are given. The speeds are 18 and 12. After how many minutes will they meet? So the first person maybe start here. After 10 minutes maybe here. The second person going to start maybe here, because their speeds are different. The first person maybe complete that revolution, that is ground, that is one circle, it maybe 18 minutes, and the second one maybe 12 minutes. So first person maybe 18 minutes means second person completed, no, so automatically this one may be here. The question is, after how many minutes will they meet? Their speeds are different now. So first person may be here, second starting there started, no, second person may be here. Similarly second person definitely their whose speed are different, whose speed is bigger, no, they definitely is going to meet the second person after some time. You may think that in a straight line form, a straight line, definitely one person, suppose 50 kilometer speed per hour, another one 70 kilometer per hour, they are going to start. 70 kilometer per hour goes on, go on somewhere. 50 kilometer, after 1 hour it will be after 70 kilometer, after 1 hour it may be 50 kilometer. So definitely they never meet in a straight line. But in the same way, it's a circle form. It's going to somewhere closer to that second person, no. So in the circle form where they meet, like that given question, means just to find the LCM of these two numbers. So now the prime factorization of 12 is given, prime factorization of 18 is given. Now the LCM of these two numbers equal 2 square into 3 square, that is 4 into 9, 36. After 36 minutes will they meet again at the starting point. So like that you can find. Thank you.